Hello and welcome to Precalc1. So, first lecture is on functions. We need to define functions and learn how to work with functions. For the rest of the course, after we do this, so first we define functions and learn properties of functions, rules of functions, which is chapter 1. Then chapter 2 you learn about polynomial functions, which will have a linear function, which is a straight line, and a quadratic and a cubic, so all of those will be polynomial. And then chapters 3 and 4 you will learn about exponential and logarithmic functions. Then you will move to Precalc2 eventually, and you will learn about trigonometric functions. And then once you hit your calculus courses, you will learn about hyperbolic functions. So there are many functions. We touch upon very few in math education. Also rational functions, I skipped on those. I will work on those as well. There's a book that contains 2,500 pages of functions, where your chapter 2 will fit on one page actually. So there's a lot of those functions out there because we model the world with functions. Everything that we build as a species rests on functions. And generally, engineering and science lags about 200 years behind mathematical definitions. One of the best examples would be complex numbers, for instance, as the mathematical idea, and then about 150 years later, Nikola Tesla used those complex numbers to create alternating currents, transformers, generators, and technically all of the technology that we today have that is based on electricity. Pretty much everything goes that way. Mathematics is first to do some modeling, then you have physics to fit that in the what you call the real world, because clearly over here it's fake. And then you have engineering that takes that physics and math and puts the practical side on it to build a product, right, which is eventually sold. So that process takes a long time. Current mathematics that is out there and being researched at universities has zero application because our obviously understanding on physics and everything else is not at the level, but down the line it will be available. Everything starts from mathematical model, which is a function. We are going to see mathematical models for population, for decay of garbage. We'll see how pre-calculus actually crowns, especially this chapter 3, how it crowns over almost every human achievement, because we will be talking about history, we will be talking about economics, we will be talking about, well, and business and money, right? We will be talking about environmental issues, we'll be talking medical stuff. So all of that would be the application of, at the end, again, exponential functions, and obviously science and physics and everything else. So we will have that, but we need to build up to that point. We start with the notion of a function, which is the definition, which I will put verbatim on the first exam, and then you either state correctly or not. That's going to be up to you. So function is a rule which assigns to each x in the domain a unique y in the range. The words that I'm going to underline are rule, domain, range, and the word unique will be underlined twice. I already said last class that this is going to be one of the classes where you are starting to move away from procedure-driven mathematics, like algebra, into more of, I have to learn the concept in order to do problems. Well, this is a definition that you need to know because calculus can be performed on functions. If you don't have a function, you can't integrate, can't do certain things. So you need to be able to differentiate which expression is a function and which expression is not a function, which is, again, the goal of this course in general, and to learn the basic functions and their properties. So now when you're looking at this definition, each one of these underlined words is extremely important, and you see that one of them is underlined twice. If you take any one of these words, definition will not be definition of a function. In case that you take any one of these words that are underlined once, the whole definition fails completely. If you take out the double underlined word, then you get definition for something else. So we have to be careful about these things. So first, the word rule. That is your equation or the formula. So that's your equation or formula. And then you have the word domain, which is input, and the word range, which is output, and the word unique is the one that actually creates the function. So if you take the word unique out, you get something that is called relation. And our job today is to learn what the function is and how it's different than relation, mathematical relation. Notation for function is f of x. That's how you read it, f of x. And this in no means means multiplication of f times x. It is f of x is the notation for the function, and we are going to write y equals f of x, which will contain x comma y ordered pairs, which eventually produce the graph. So an example of the mathematical function which you've seen in algebra course would be y equals 3x plus 2. You can write it this way, or you can write it f of x equals 3x plus 2. One or the other. It doesn't matter, because this is what you are remembering. Y equals f of x. We are going to understand now that x is input variable, in domain. So those are all of the numbers which you will be plugging in. And y is the output variable in the range. Range, so domain and range are set of all either input or output values. You can also think of this in terms of graphical approach if you want to, if that helps. X comes in, F operates on it, Y comes out. And to illustrate that very quickly, if I say f of x equals 3x plus 2, which is what I had earlier, then f of 5 will be 3 times 5 plus 2, which is 17. Note that the point is 5, 17. That's x and a y. You plot that on a graph, and the line will go through that point. So function is a rule which assigns to each x in a domain a unique y in the range. And you have these x's which create the domain. Those are the values you plug in as input. and you have y values, which is range, which is the set of all output values. And we also have the word unique, which ties together these variables. You also have the name independent variable, which would be x, and dependent variable, which is y. It's called dependent because it depends on x, which number you're going to plug in, right? Cool. Another graphical representation here would be to draw two sets. Say that this is your domain set and this is your range set. You can have elements x1, x2, x3. And then on the other side, you have, let's say, y1 and y2. I'm going to map assignments this way. So function is the one that will take these numbers from, they will take the numbers from set 1, from domain, into the set 2, which is the range. So in the case of our example, I would have a whole bunch of numbers on this side. One of them would be number 5. And then I'm going to have a whole bunch of answers on the other side. One of them will be 17. And the mapping from one to another would be this f of x, which is the formula we use to calculate. So 3x plus 2. So when you plug in 5 for x, 3 times 5 is 15 plus 2 is 17. So we take one by one numbers from x, from domain, and we compute them one by one in the function, which is the formula we have, and we obtain, again, one by one, we obtain the y values that are matched with the x's. So I hope that it's a very simple mechanism to understand, but we can also use examples all around us. Remember that mathematics models the world. So far you have seen algebra, but I will argue as a math professor that algebra is probably the most boring math subject in the galaxy, because you learn the procedure and pretty much every problem is monkey sees, monkey do. There is no much of application that you get to do or experience those math concepts. You simply learn that if you are multiplying x squared with x to the 8, you add exponents, you get x to the 10, and such is life, right? But as soon as you start moving to pre-calculus, we're going to see a lot of application in this. You have the project as well to enjoy. You will see how mathematics give base to technically everything you see, everything you touch. The only subject that lags behind is biology, which is why we don't know much about biological systems. People are memorizing and learning a lot in those courses, which I could never achieve because I don't have that type of patience. I admire people that do. Biology and organic chemistry are not mathematically mapped, which makes them insanely complicated. That's why you have to learn and memorize a lot, because there are no equations which would give, like in physics, a very simple framework to work in, and then you can, build systems. So that's why we are not able to build a human being like this, but we are able to build a computer. Because remember, computers have mathematical background, they have engineering background, they have physics background. So we are able to build cars, computers, and things like that. We can't build biological systems because we don't have that mathematical math. And mathematical biology currently started developing in, let's say 20 years, is one of the hardest fields of mathematics due to number of parameters and interactions and so on. But now, when you're trying to look at this situation for our class, I'm going to explain the function by simply touching the light switch here. What is the function of the light switch?
On and off the light.
On and off. Okay. Should we just say to control the light? Now, which light? There is also light in Germany somewhere. Ukraine has light. Which light does it control?
Many lights, so it's exponential.
It controls these ones, right? That's what it is. See, this little switch over here uniquely controls lights in this classroom. And that's that uniqueness. This over here is called an input. This is your X. I can use the nose as well, or someone's head. I'm talking. As I use the input X, changed state of the light is Y. Because that's the outcome of X input. So, right? Right? So, the function of the switch is to uniquely control these lights. I can rewire that thing. I can take, does anyone have a remote starter for the car installed? Good. So I can actually wire this to start your car. Yeah, because every switch has the same principle. It's just two metal contacts that do this and do that. Whether it's on your keychain or in the wall, it doesn't matter. Whether it's red or white, it doesn't matter. Well, every switch on the planet works the same way. They have different size, different shape, different color, but they all have the same purpose, to open or close electrical circuit. What I need to do is to take the guts from your keychain and take that and just replace, right? It will still have the same purpose, except you will not be using the casing of your case because I took that out. You'll be using this switch. But then, does it control the lights? You see, that's the trick of the function. Single input produces the single output, and it produces the single same output every time. So, in this function, for all of us and everyone else, when I plug in 5, when you plug in 5, and you plug in 5, and you plug in 5, you will always get 17, because the unique answer is 17. It's not going to be 17 for me and 13 for someone else and 105 for someone else, because the uniqueness in that case is ruined. The definition of the function states that for each x from the domain, there is a unique y in the range. Now, are there equations where you can get two different outputs from the same input? And the answer is yes. I can show you one right now. They're natural as well. I write on this tablet using input device. Observe that we actually have 3 different outputs happening simultaneously. And they're all different, and uniqueness is completely ruined. Output number 1 is directly on the tablet where I write. Output number 2 is the one that you see on the projector. And the output 3, remember the class is streamed live, right? So that is not a function. It's not a function. So to have function and not function is nothing about natural and unnatural. It is about learning the definition, whose meaning is, as I explained, and then you have to make sure that the equation or the concept you're working with is function, not a function. For instance, let's say you have a race. Race will have 8 people running, let's say. So those 8 people will all have different numbers. So one person is number 1, number 2, number 3, and so on. The assignment of the name of the person and the number is function. But the race itself, the way they finish the race, doesn't have to be. Because 2 people could finish at the same time. Right? Which means all the input, right? So there's a lot of different things that you can think about, and your first lab will ask you to go on Google or whatever and research. Find situations where a certain data set is function or maybe not a function, right? So, in a nutshell, what you are allowed to have in order for a set of values to be a function and what you're not allowed to have. So here is the situation we already seen. This situation is a function. You can think of this as instructor is in the classroom. All of the students, 40 dots over here, are in the classroom. That's all okay. We all get to be in the same classroom. That's a function. What it's not allowed, and you will see that here, is that the single x input, that could be you, branches into 2 separate outcomes, y1 and y2. Not a function. Uniqueness is ruined. You have 2 answers for a single input, and you can think of it as, well, I can't be in 2 locations at once, right? Let's say home and in school. Unless you live in school, in that case, yes. We can also detect this through ordered pairs. Say you have a set of ordered pairs, 0, 1, 3 and 4, and 3 and 6, and 4 and 1, and -3 and 9. Is this a function or not a function? Why is not a function? Where is the issue? What happened? Yes. So this is the issue here. There's the issue. A number 3, which is always the input. It's always x comma y. X is always input. Number 3, which is the input, gives us 4 and 6. Essentially, this situation. Number 3 gave us 4 and 6. And that's no bueno. So, not a function. Now, I heard someone mention something about 1. Is this situation okay if it happens? Let's say that these 2 are not in a set, or one of them is not in a set. Would this break a function? Yes or no? No. It would not break a function because, look, 0 input has 1 as the output, and we don't have any other zeros to give us a different output than 1. I can have, if I want to, 40 different numbers map into 1. Aren't we all in this classroom? Right? 40 of us are mapping to 3, whatever the hell this is, 247, right? So if I go around and I say, what's your G number? What's your G number? What's your G number? What's your G number? Let's have, all of you have your unique G numbers. I have my own G number. We are all this value of the point. This is student with the lowest G number. Then this is the next student up, and the next student up, and student, right? Because we can put those G numbers in the ascending order. Now, what is your y value in terms of location? Every single y value would be S247, 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 right? It is a function. It is a function because every input, right, produces a location. You will not find this situation where a G number, whatever, and the same G number, whatever, is in one and the other classroom. That would mean that you are here and next door, or somewhere else, at the same time. So, situation with ordered pairs or picture-wise, right? Whatever way you look at these things, you have that this is a function because, oh sorry, if this situation wasn't happening, right? This would not ruin the function. It will be fine. It will be fine. So I'm just going to erase those so we don't have issue in the notes. Hopefully you guys got it so far. Domain is the set of all input values. That means set of all numbers which I am allowed to use to plug in the equation. Sometimes you are not allowed to use certain numbers to plug in. For instance, divide by 0. That's an issue, and I'll explain why eventually. So, if you are trying to connect what I'm talking about in terms of the domain, we can sit out here and have fun a little bit and trying to figure out what is the domain of the light switch. What could I use other than a finger, right, to press against the light switch to change the state of lights? Anything that we come up, you take a shoe and you press it with a shoe. As I said, you use your nose, right? You use your knee. Take someone's head and push into it, right? It will all work just fine. My question is, and we can go on and on with, hundreds of objects and things that we could use. How about the list, which makes it fun now, of things that we can't use to excite the switch? If you say air, I will say, well, compressed air, right? It's still air, so yeah, we could use compressed air. We could compress the power washer water, that should work too. Can we figure out some of the stuff that we can't use? Fire, very good. Fire would not be very useful in turning the switch on, yes? That's true, unless you're a Jedi. But yeah, we haven't evolved to that level yet, so maybe eventually, right? So good. So far, we can't use the thoughts to turn the light on and off. Okay, cool. So fire thoughts. Let's bring one or two more, just because it's fun. I like to see what you guys. Yes. Yeah, we'll probably break the whole thing. Yeah, I'll give you that one. Why not? Yes.
A soccer ball. You could use a soccer ball. You're making up a list of things you can't use, right?
Can't, yeah.
Water. You can use ice cubes, so you can't use water.
I can.
It would turn.
Yeah, this is what I use for like a behavior correction device in the last few years. It works up to the row 3, maybe 4, right? But see, it's pretty good, right? It's pretty good. So power washer would definitely work on switching it on and off. So we can compress the water to do it. If you submerge it in water, it won't. It'll just. Anything else?
The light switch.
The light switch. What do you mean?
Using the same light switch to turn it on or off.
Wow. I never had that one in years. I've been doing this exercise for years now. Can't use itself. That's very. You should be philosophy major, my friend. That's what is your major, by the way? Whatever it is, just stop wasting time. Just go to philosophy. That was an excellent. That was amazing. All right. You had your hand up.
Can't pull it.
Can't pull it.
Yeah.
Exactly. If you pull it out, it doesn't work. All right. Great. Good. Nice. One of the cool answers from previous years is jelly. Can't use jello. You know, doesn't work. My favorite example is the moon. Right? You can't use the moon. I got that idea after Despicable Me because you just, you know, when you shrink it, then it's. But see, that would not. That let's discuss that. The gravity and that much would be such a big problem. You wouldn't be able to walk around with it. I mean, come on, you can't contain that much. That's how you create black holes. So they got that part wrong. I wrote an angry letter, and they didn't change it. Tough luck. Great. So I hope we understand the domain. Domain is the set, in our case, mathematics, set of all input values that you are allowed to plug into a formula. Range is the set of all y values that you get back in return as a consequence of plugging in x's. So if I write a function, let's say f of x equals 1 over x. Upon careful consideration here, we see that we can plug in any number except 0. So, what would be the domain on this one? It would be negative infinity to 0. And when you put a parenthesis, you are excluding 0 from the set. Union 0 to positive infinity. So this is how you write in pre-calculus. This is how you write everything but 0. Right? So this statement here, I'll put it in purple. Everything but 0. That's technically what it means. When you're writing sets, right, you have the parentheses like this, which means do not include endpoints. And when you have these puppies, include endpoints. And we will have to use these. Now these correspond to less than, greater than, and then less than equal to, greater than equal to. We will have much more of these uses as we go through the class. So now when you're looking at the function 1 over x, you see that that function can take on any value for x except 0. 0 is the only number that has to be excluded, and we say 0 is not in the domain. This is insanely important for your calc class because you will have to work on wait, this is loaded. You will have to work on a particular domain in certain exercises. You look for critical points and stuff. You will need to know which points or which intervals are excluded from the domain so you're not wasting time in those regions. How about f of x equals square root of x. What do you think about that one? Do we know what the domain is? Anyone? When we are looking for the domain, what are we looking for? The x values which we are allowed to plug in, right? So what would be the set of x values which I am allowed to plug in? Any?
Positive.
Positive numbers.
And, numbers that are squared.
Well, they belong in positives, so sure. Right? Positive is bigger than that. Anything else? So positive numbers. Anything else? And 0, guys. Square root of 0 is 0. That's cool. We are not in this particular case, we are not allowed to plug in any negative numbers. So the domain for this one would be including 0 and obviously infinity with the parenthesis because we don't get to include the infinity. Only one person can count to infinity. Who? Who can count to infinity? No. Oh, no. Yeah, this reference is not going to... Chuck Norris. I know. He is the only one who can count to infinity. Twice. In 5 minutes. Now, if the half of the classroom goes, what the hell is Chuck Norris? I'm just sorry for you. Right. So at this point, I'm just going to see, because it's a new edition of the textbook, so I just don't want to miss any of the points that are in the new edition. But as I can see over here, all they did is they changed the cover so far. Yep, definitely cover is different. What the hell is this? That's wrong. Look at that. I don't know, it just looks weird, right? But it's really interesting to look at the last line of that. Can you read it quickly? Do I have a volunteer who like actually stand in front of the classroom and read this line? You want to try? Come on. It's going to be fun.
Blue, yellow, red, green, yellow, green, blue, red, yellow, red.
Nice.
Yeah.
That's actually very tough.
It's
So
tough because the yellow is in green and I see the trick.
yeah.
Not that on.
Well, some people can filter it. Awesome. Now, do we have people who speak multiple languages? Do we have someone who speaks 3 languages? 3. We'll start there. If not, if you speak 2 languages, can you count simultaneously in both languages? So you go, jeden, 2, 3, 4, right? And so on. Try that. See how insane it is. Generally, I can go quick to about 15 to 18, depending on the day, and then I'm dead after that point. Anyway, exercise your brain. All right, so the next part here is to talk about the, so we'll have more on this domain situation in next section. What we need to deal with right now is, well, first we understood from this domain that there are certain numbers that we are not allowed to plug in. So we don't consider parts of the x-axis, the part of the graph, where that graph does not exist. So I'm going to show you how the square root graph looks like. You will be memorizing these basic states of graphs anyway. So this is how the square root graph looks like. That's the square root of x. And as you can see, there is a void on this side of the graph. There is no line. So if I am at 1, I am able to bounce off of the function and get 1 as the answer. If I'm at, let's say this is a 4, I would bounce off into 2. Because square root of 4 is 2. Remember, x input is 4, y output is 2. So this point here is 4, 2 on graph, but it's a single 4 on x-axis and a single 2 on the y-axis. So this is how these functions work. You would have to go either up or down from x-axis to hit the function, and then immediately bounce parallel to x-axis into y-axis to see what the answer is. Observe that if you are to use -2, you would go looking for the function infinitely down and infinitely up, and you will never hit the function to bounce into y-axis to find the answer for square root of -2, because the function is not defined at -2 at all. It doesn't exist. -2 is not in the domain of square root of x, but we already know that, right? Because it's outside of the domain. So there are these concepts that work together simultaneously, and that would be the equation that you get, the picture that it produces, and then the picture will only take on the values, right? The graph would be above the values where the domain is. So that's how these concepts work together. Now we need to understand that every equation you write is going to have associated picture. Note that I said equation. I didn't say function. I said equation. Circle is an equation. It's not a function. I spent the entire summer practicing, so let's see how that... I draw perfect circles now. There we go. So if you look at the circle, let's say radius 3, it will have equation. Now, you are supposed to know this from your intermediate algebra class. X squared plus y squared equals to 9. This is exactly the equation that will be skipped in 1.9 because you already know this stuff. So you have a circle with radius 3, and you have the associated equation. Is it a function? Hell no. Why? Well, pick any x value between 0 and 3, let's say. Pick a value. 1. 3 is the worst possible one you can pick. I said between 0 and 1. All right, so 1 was screamed first. I like 2 better, but that's okay. 1 will work as well. If I draw vertical line through 1 and all the way to hit the graph, you see that it bounces on top and the bottom, creating 2 different y values. Do we see that? Right? Right. Can we detect this behavior in our equation? Sure. Plug in 1 for x. We get 1 squared plus y squared equals to 9. You get y squared is equal to 8. Right? 9 minus 1. And then you get, when you square root both sides, don't forget to do plus minus, right? You're square rooting both sides. So y equals plus minus square root of 8. So y is equal to plus minus 2 root 2. Do you see that a single input, x equals 1, produced 2 different outputs? Therefore, not a function. Uniqueness is ruined. Single x, 2 different y's, uniqueness is ruined. This cannot be a function, and it's not. So whether we have the equation, or we have the picture, or we have the sets of values, we can determine if something is a function or not. Guys, that's the goal of our section today. To learn the definition, to learn the notation, we're going to do some calculations soon, and then also to be able to recognize when certain equation or a graph is a function or is not a function. Now, look at this vertical line through 1. I would argue that that's actually something that we can use all the time. Because if I am able to cut through the graph 2 or 3 times, uniqueness is definitely ruined every time. So, we have something that it's called vertical line test, which would test if the graph is a function or not. For instance, say I have a linear line going through xy. If I draw these vertical lines everywhere, note that they cut through the graph exactly and at most once everywhere. No matter where you draw this vertical line, it will cut through the graph exactly once. We would say in that case, passes vertical line test. So graph is a function. In Precalc1, you're going to learn about sideways parabola. It's going to look like this. This equation is x equals y squared. If you look at this one, you draw these vertical lines, it fails every time except at 0. Passes once, it fails infinitely many times. Fails. VLT immediately means not a function. Vertical line test is the fastest way for us to see, obviously, if the graph is a function or not a function. But when you write the equation, anytime you end up with a y to the even power, it's not going to be a function immediately. It's dead right away. Y squared, y to the 4, y to the 16, y to 100. Anytime you have an even exponent on y. Odd exponents are functions. Because if you have x equals y cubed, you cube root both sides, you get y equals cube root of x, and that's a function. So we are a little bit limited with equations, right, when you look at the equation. But then if you have the graph for that equation, you can immediately use vertical line test to judge whether that particular equation is function or not. Now you would say, well, wait, is that more work? Yes, it is. Welcome to pre-calculus. It's more work than your previous classes. If you have issues with graphing, immediately adopt the middle school method. It's still valid. You pick your x's, compute y's, connect the dots. That always works, 100% of the time. But we are actually going to focus in this class on memorizing certain default states. And then in section 1.6, we are going to learn how to move these. So not next week, but the following week. Oh, actually, no, next week, because we do 1.4. All right. Cool. So that's that part. And I just wanted to ask you to work a few of these calculations. This is the most basic stuff for functions. I will give you that f of x is equal to 2 square root of x plus x squared minus 1. I will ask you to compute f of 0, f of 4, and f of b. So we are going to plug 0. We have 2 square root of 0 plus 0 squared minus 1, and the whole thing is -1. Then we are going to, what happened? 2 times 0 became 2, and then 2 minus, right? Oh, okay, I see. Yeah, I know those symptoms are around. They go away after some time. 2 times the square root of 4 plus 4 squared minus 1 is equal to 4 plus 16, 20 minus 1 is 19. The last line is asking you to replace x with b, so that's what you do. So just in this class, just be nice, okay? Don't discriminate. If in the first line you replaced all x's with 0, and on the second line you replaced all x's with 4's, well, in the third line replace all x's with b's. Yeah, I know, tough luck, you can compute, but it's not all about computing everything, all right? It's more of a following directions. So, this is your input, and observe how it matches across the board. X, 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 0, 0, 0, 4, 4, 4, B, B, B. Bueno? If I do this, then you will complain it looks like 8, so I'm not going to do anything. Yes?
So, shouldn't we have done ordered pairs with parentheses after the first one 0 and then -1?
You can. Very good. That's another thing that you can add to the whole thing, which is that the input 0 produced -1 as the answer, which would be a dot somewhere on the graph. Number 4 produced 19. And the last one is a little bit tricky. Value b produced 2 root b plus b squared minus 1. That's actually the y value. You can't compute it, so you just have to write the whole thing. So the third order pair actually looks like this. That's actually a very good point to add to this question. Nice. When calculations become too much, then you can obviously use abacus to compute things. And I hope you're not disappointed, but that's it. That's 1, 1 and 1, 2. And now we're going to jump into 1, 3. Again, 1, 1 is not in the syllabus because some of these concepts you were supposed to know already from your intermediate algebra. But then section 1.3 with a very, very funny title, More on Functions and Their Graphs. So let's, I'll restart the stream so you have the new file for it.